Modern AI can pass the bar exam, write flawless code, and draft college-level essays in seconds. These systems generate human-like text by predicting statistical patterns, operating without any comprehension of the words they produce. When DeepMind's AlphaGo defeated world champion Lee Sedol in 2016, it made moves so creative that experts believed it possessed a strategist's mind. Look at the faces in this room. The human emotion is palpable. The algorithm they are shaking hands over felt absolutely nothing. This convincing display of intelligence rests on cold mathematics. These systems function as mirrors, reflecting the patterns found in our own collective data. To see how this trick works, we have to discard the idea of a brain in a box. An artificial intelligence is a statistical engine optimized to process arrays of numbers. At its core is an artificial neural network, structured like an expansive, multi-layered filtration system. Raw data, like the pixels of an image or the text of a prompt, cascades through hidden layers of artificial neurons. When the AI answers a question, the data simply falls through that plumbing, finding the mathematical path of least resistance until it exits at the bottom as a final result. Zooming in, a single artificial neuron receives signals from above. Each connection has a weight, a dial adjusting an incoming signal's importance. Inside is a bias acting as a circuit breaker. The neuron totals these signals, firing only if it crosses a specific numerical threshold. A neural network contains billions of these dialed settings. When aligned, they filter chaotic inputs into precise, accurate outputs. When a neural network is first built, all of those billions of dials and circuit breakers are set to random numbers. The system produces garbage. It must be trained from scratch. To train the model using gradient descent, imagine a person on a vast mountain seeking the valley's lowest point, representing zero error. The system makes a guess, calculates its error, and steps downhill. This correction flows backward, tweaking every dial along the way. This cycle repeats across billions of iterations, scaling rapidly through training data. Machine learning functions through the relentless, mechanical optimization of the system's own failure. Large-scale text models like ChatGPT have completed this training by ingesting the text of the internet, mapping linguistic patterns into their finalized parameters. These systems do not read words. They slice language into mathematical building blocks called tokens. A bar chart shows the probability distribution for the next word. The model locks in the most likely token, feeds the sequence back into itself, and repeats the loop. The appearance of a thoughtful conversation results from the machine executing a sequence of high-probability guesses at high speed. In 1980, philosopher John Searle proposed the Chinese room thought experiment. Imagine you are locked in a room, receiving slips of paper with Chinese characters. You speak no Chinese, but you have a rule book that tells you exactly which symbols to send back in response. To the people outside, you appear fluent, but you are just matching shapes. AI operates exactly like the person in that room. It is a master of syntax, arranging symbols flawlessly without ever grasping their meaning. Human intelligence relies on semantics. We perceive the continuous flow of time, build a stable identity, and make intuitive leaps based on physical experience. A machine lacks all of that organic context. It remains trapped between input and output. It can mimic our collective knowledge, but it is incapable of originating an independent thought of its own. Strip away the interface, and all that remains is math, weights, and the strict minimization of error. This architecture represents the culmination of a century of computing, scaling from Alan Turing's early paper machines to the foundation models powering today's search engines and translation tools. A machine produces results without being alive. Its power lies in its capacity to predict, with mathematical precision, what comes next.